talked about a bunch of stuff that you need to know before you start programming in Python. And in this video, we're already programming in Python. So the first part is going to be on data types. Data types are those very strictly defined units that your programming language, whichever one you choose, in this case Python, uses to store and work with information. So we're going to go through the most common data types used in Python and quickly explain how they're used and what they do. But before that, a very quick recap. What's happening when you are writing code like this? Well, what actually is happening is you are writing those instructions right here. And then when you, in the case of Sublime, press Control B and execute it in the terminal, what's happening is this code is then passed on to a very special tool that works underneath. That's called the Python interpreter. That's also written in a programming language. In this case, the programming language is C. And then this tool then translates everything to computer language, and then your processor and your RAM executes the task and gives you the result that you want. This is what's happening. So you need to know the exact instructions, otherwise the interpreter underneath is going to be confused. The good thing about an interpreter, what Python uses, is that it goes through each individual line from top to bottom, and if you have an error somewhere, it's going to tell you. So it's not going to let you break everything colossally. You get to correct everything line by line. Okay, let's move back to the data types here. So like we said earlier, this is very much like in a human language. Data types could be equated to verbs, nouns, sentences, stuff like that. It's just a very specific thing. It's a very specific unit that you need to use in order to handle information. And we're going to start with the string, the thing that most beginner programmers usually start with. And the string is much like this here, just a sequence of characters, which could include letters. It could they could include a string could include also punctuation, numbers, special characters, and also even parentheses here, as long as they're different from those right here. So they have to differ. If you use a big one here, you have to use a small one here, and other than that, that's it. You can include almost everything you want here. You can think of this as a chunk of information. For example, a very large book. If you open on a random page and you grab half of that page, this chunk of information could be stored in a Python string. This could be a name. This could be, well, all kinds of stuff. And most beginner programmers are going to learn the print function. This is built into the Python interpreter. The Python interpreter, by the way, we install when we install Python on the system. In this case, this is a Linux, so it's pre-installed. And we can use the print function in order to input this information here. So in this case, we created a variable, which we're going to discuss just a bit later. We created a variable, and we're going to print the contents of that variable using the print function. This is built into Python. So if we execute it now, we are going to get this string. And let's immediately demonstrate how this could end up being very useful very quickly. This is a formatting string. This is a way for you to play with, to modify strings in Python by using this F right here. This is for the newer versions of Python, or format here for the older versions of Python. So what you are going to do here using the formatting string is you're going to take one string and insert it into another string. So this is the syntax right here. You could also just Google Python tutorials or go to YouTube and browse and learn from thousands, literally. So this is just a very quick speed run of what you can do with Python, and a very quick introduction before you dive in and learn more yourself. So here we have the formatting string. Once again, what it does is it takes this variable and it inserts it right here. So now when we print this one, and by the way, we feed everything to another variable. Once again, variables will be discussed a little bit in more detail towards the end. And let's print and see what's going to happen when we print this one now. Now, what's happening here? We're using formatting strings in order to insert the contents of this variable into this string. So we're creating a brand new string How could this be useful? Well, imagine now that you have, for example, a list of names. Let's say for a company or something, you have a list of names, and this is an Outlook signature. Then you want to generate an Outlook signature for the entire company, but you're not going to sit down and type in the name for every single employee. You are instead going to use a formatting string script for Python, and you're going to generate 300 signatures in 5 seconds. So let's execute this and let's see what happened. Well, first we get this string right here, and then immediately afterwards we get, well, the remainder. We get this. So now this equals, first we inserted all this text here, and then space, like we have here, and then the rest of the string. So this is formatting strings. It's just a way for you to insert things into your strings. And this is the old way of doing it. This is still valid. You can still use it even in your versions of Python. Don't let this 0 here confuse you. The 0 is not necessary. So this is just a placeholder, much like here with those curly braces. This is a placeholder. It could be a 0, it could be nothing, but if you put a 0 and then later on you have another placeholder, let's say somewhere right here, you have to iterate, you have to make it a 1. So now, for example, you can insert 2 different things, right? You could insert 1 here and then another here, but of course you have to add it here in the end. So we don't have another variable handy, or do we? Actually, we have the formatting string. So this is going to get super meta like this, and let's print it out. And now we have, for those of you who are willing to follow, we have here the first placeholder, which is with the format function, another function that is built into Python. So you don't need to import anything, just learn how it works and start using it. So we have the first placeholder that's going to be filled in by this variable right here, which happens to be this long one. And so we see that this is the first thing that is printed onto the screen, into the console. And then we just start our sentence. We just start our string here that we're modifying. This is also A, so we get this is also A. And then we get the second placeholder, which we filled with this string here, which is getting really, really meta at this point, getting pretty confusing. So let's get rid of this. Let's get rid of this real quick. This is just the old way to do formatting strings, like this. So you could either use the F right here, or you could use the dot format, calling a method dot format of the string type here. So you could use the F string or just use dot format and add it this way. Okay, let's comment this out. By the way, every time we use this this hashtag here, this comments everything out, which means that the Python interpreter, when it goes from top to bottom, line by line, is going to skip those. It's going to see the hashtag and say, oh, this is a comment. There's nothing to execute here. Let's move on. There's nothing for me here. So if I hit Control B now, nothing's going to happen because we're declaring here a bunch of variables, but they're not doing anything. They're just getting stored in memory, and then the program reaches its end at the end of this entire very, very long script. And it doesn't execute anything. Nothing happens because there's no logic to it. It's just declaring variables. But that's the point of the tutorial. So let's move on now. That's strings. And now this here is the numeric types. We have integer, we have float, and we have complex, which is some kind of a math unit thing that I have never used. If it's useful to you, well, good luck researching more on complex. And here we have a couple of examples. We have x equals 5. We have a negative number that's also, as you can see, significantly larger, but this is still going to be an integer. And we have a float. A float has a decimal point somewhere in there. So it's not a whole number. And this is the whole difference between integer and float. The reason why they're different types and do different things, or slightly different things, is the way they is because they're stored in memory in a different way. So an integer is just allocated an address and is given a certain size right away. In this case, just 1 byte. Very easy. In this case, lots more bytes. But a float is stored in a very specific way. Remember that this tool that runs your code in Python, called the interpreter, is written in the language C. It's not written in Python. It could be, but in this case, it isn't. And so an integer is just given some address in memory, and it's given a set size, but a float is a little bit more difficult to store. It has to be given first this bit right here, certain amount for this bit, and then a certain amount of space for this bit. So that's why there's a slight difference here. But the cool thing about the numeric types is that you can do arithmetic with them. Now with strings, you can do arithmetic. You can say something like x equals 1. Oh, that's not a 1. X equals 1 and y equals 2. Those are strings. Remember, they're defined by the entire contents are locked in those parentheses here. And you can say something like z equals x plus y. I mean, let's comment those out. That's another way to comment things out, but over multiple lines with 3 open parentheses like this. And let's print z now and see what we're going to get. So what we're getting now, 12. This is another string. It's not a whole number. It's not an integer. You cannot do arithmetic with it. Why did we get 12? Well, it's because it's just treating those as strings, and it's concatenating them. It put the two together. This is the 1 and this is the 2. So if we change this to, let's say, 7, and now we're doing 7 plus 2, we should get 9, but we will get 72 instead. It's just because it's putting them together. So strings behave in a very, very different way from integers and floats. Integers and floats, with those you can do arithmetic. Like we can demonstrate here. We are going to combine x and z, x and z, and we're going to get something like 16.7 blah blah blah. Let's see what we did wrong. Well, z is very much defined. Oh, okay, we forgot to delete this. Like we said, so the Python interpreter goes from top to bottom, and when it reached line 41, we told it to print z or z, but there is no such thing. We haven't declared it yet. So we declare it here on line 48. So the interpreter was like, hey, wait, there is no z. And this is pretty useful. This is why Python is so beginner friendly, because it tells us that we have a mistake right here. We didn't even need to run the rest of the code. So let's execute it, and we get the 16.7 blah blah blah, because we're printing now x plus z here. X and z, those are the integer and float, and this demonstrates also that you can combine integers and floats. You can do arithmetic with them. You can subtract. You can multiply if you want. It works. They're just different types because they're stored in a different way in memory. And so there are other things that you can do with integers and floats. You could, for example, use... so these are not built in Python. You have to import them, but you don't need to install any extra modules. This module comes already with your Python installation. It's just not in the core Python list of functions that you can use, like print, for example. But you have the floor function and the ceil function, and those take floats and turn them into integers. So let's print now, and we have x plus z. Remember, this is 16.7 blah blah blah. And we have the floor and the ceiling. The floor rounds it down and the ceiling rounds it up. So in case you need to do some arithmetic, this is the data type that you're going to use, either an integer or a float, but not a string. A string is just a predictable sequence of characters that is always like that. And later on, we learn probably that you can also do a little bit more with it. You can iterate over it, meaning that you can say for a string here, for example, give me the character in position 7, and then it's going to fetch this comma, for example. Or you could say for each character, if it is a comma, take it out, or something like this. So this is, they have just different powers. You can think of different data types of having different superpowers, if you will, that are going to allow you to do whatever you want to do, but you need to use the correct one, the right one for the job. And there's another thing that you can do. For this, you don't need to... you really don't need to import anything. This one is the int built-in function into Python. What this does is it takes a float, because remember, if we do x plus z, we will get a decimal point in there, which is going to make a float. But if you say int before that, well, it's going to turn it into an integer. So let's quickly print that out. And it became an integer. X plus z, 16 point blah blah blah, became 16. Now it's an integer. So you can also convert different data types from one to another. In fact, why don't we make it a string, for example, like that? Now we get the full result, but this is a string. So because we converted it. If we say something like, let's create another variable. Let's say another variable, and we're going to say that this equals converted float. This is this one, which is now a string that combines x plus z. This is probably getting confusing if you're an absolute beginner, but you could rewatch it or just get some basic information, a little bit more, and then rewatch it again, up to you. And then now let's get the string and let's try to concatenate it, to combine it with a whole number, with an integer. Remember, now this is a string and this is an integer. What do you think is going to happen? Can you, well, we don't need to do a print function. It's going to return an error here already. Can you combine string with an integer? Well, the answer is no, you can't, because they have two completely different superpowers. They're two completely different units, completely different things that you would use for different tasks. A string you would not use to perform arithmetic with, because it's useless for that. But if we have an integer here, now it's going to work. It's not going to return an error, at least, but we forgot to print it. So let's at least see our result. And now it works. Now it works. Now it returns 22. So pretty useful stuff. Again, just remember, they're two different, completely different tools used for completely different things. You would not use strings for arithmetic. Okay, so let's comment that out and move on to sequence types. Sequence types is just different ways for you to store multiple bits of information in a sequence. Now, range, I'm just going to kind of go ahead and skip that one because it's not that important for beginners. Or actually it is. Maybe we cover it. So we have lists and tuples at the beginning. So lists, this is an example of a list. It uses those square brackets right here. And each element of a list is separated by a comma. So you have element 1, comma, element 2, comma, element 3, blah, blah, blah. And as you can see, you can have everything here. You can have a string, and then you can have a number, a whole number, so an integer. You can have another string. You can have another whole number. And by the way, this is a negative number. You could also use, for arithmetic, of course, you can also use negative numbers. In a list, you can also store another list. So this is a list within a list, which is stored as the item number 0, 1, 2, 3, 4. So this is the fourth item of this list. It's another list, which is, I know, it can get pretty meta. Soon enough, you can have here another list, and in it another list, and you can go crazy if you want. So let's go ahead and print. Let's go ahead and print the list. This is how it looks out when it's outputted to the console. Basically exactly the same as when you declare it. And now let's access different elements from that list. And how would you do this? Let's uncomment this here. Well, using those square brackets and specifying the index of the element that you want to access. In this case, we're saying 0. It's because we start counting from 0. So this is 0, 1, 2, 3, 4. And item 0 is, well, that's rather confusing. I've called it item 1. Let's call it item 0. Item 0, it's going to get returned here now. It's going to get printed out to the console. Item 0, because this is how we printed it out. We specify the name of the list, and then in square brackets, the index of the item we want to access. So not only is it predictable where each item is going to be, but you can call them at any time like this. So you can get any item out and use it for something. Lists are incredibly useful, and you're going to work with lists a lot. So here we have the first element, And what happens when we do -1? Well, when we do -1, it just starts counting backwards. So -1 is not this one, it's this one. So you get the last element of the list. So the last element of the list is a list within a list. It's another list. Let's print it out. So now we have 4 print functions uncommented here. The first one prints the entire list. The second one prints the item 0. The third one here prints this one. Wow, this is getting confusing. And the fourth one is printing the last element, which is a whole list right here. It's a list within a list. The point here, you don't need to follow everything exactly. It's just that you can access any item of this list at any time and use it however you want. So let's uncomment that one as well and show you how you can slice those lists and print a whole range of those at the same time. And of course, we're using print now, but later on you could use other things. You could modify those. You could use them for your programs, right? They could be useful. It's not just about printing into the console. And now with this range, this is how we do the range with this column. First element, column, end. So beginning, column, end is going to print the range that we wanted. So in this case, it's from 0 to 4. So it's 0, 1, 2, and 3. It's going to skip the last one. So it printed the first 4 elements right there. So you can also grab a whole, like you can reach with your palm and grab several at once. You don't need to just do it one by one. Okay, let's comment those out again. Remember, we could just do it like this a bit quicker. There's also a shortcut in Sublime that does it quicker, but I don't know it. So let's now let's learn another function that's built into Python that's super, super useful. It's the dir, dir function. So we have here my first list. We've created this variable and it's a list, the one that we've been working for. And now we're going to print the dir of that list. And what this does is it's going to give you all the cool stuff that you can do with your list, all the functions that you can do. At the beginning, or the methods rather, at the beginning, let's ignore those dunder ones. This is something for object-oriented programming and classes and stuff like that. That's going to come later. But let's focus on those cool ones down here. So we have append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. What those are things that you can do with lists. Those are really, really useful methods that you can use to modify your lists. And I encourage you to go ahead and create a list and try basically all of them and see what they do. So append, for example. Oh, I think I have it as an example. So append we're going to do right now. Clear, copy. Well, I don't know what extend does. I should myself try it. And pop, for example, will pop the last element of the list and just delete it. And yeah, reverse, you can probably guess what the reverse will do. And sort also, you can guess what that will do. So let's, now that we know how to get those available methods, keep in mind that you can use this for other data types as well, not just for lists. Let's do it for an integer. So this is an integer, converted float. Let's grab this and let's do it for it as well. So let's go here and use the dir function to get all the methods that we can use on an integer. Now let's ignore the dunder ones. That's for the classes and objects later. And let's focus on the things that we can do with an integer. So we have conjugate, big length, blah, blah, blah. I have no idea what any of those do and I have never used them. But maybe you could learn them and become a better programmer. Well, actually, that would not be difficult because I've just used Python for scripting for a few months. So you are definitely going to become a better programmer. Just keep watching and keep reading and you get there. So let's comment that out. And what we could do now is use one of the dir methods for the list, which was a count. And what this is going to do is it's going to, oh, okay, so this doesn't exist anymore because we changed it. Stupid. Okay, so what it does now with count is it goes through the entire list and each element that matches this string right here is going to be counted. So if we have item 1 once, it's going to return 1. But if we have item 1 twice, like that, and think about all the possible ways that this is going to be useful. What if you're looking for everybody in a huge database that's called, let's say, John Smith or something like that, and you want to know how many John Smiths are there? Well, that's how you're going to find out. Now it's going to return 2 because we have this item 1 twice. Okay, so let's restore our list to its previous form, comment that out, and wait, what's this? Okay, so now we're going to use the append method of the list. We're going to first uncomment this variable here. So we create a variable called additional information, and this is just a string that says hi from the last index of your list. And we're going to use the append function of that list. So my first list dot append is going to use that append that we saw in dir, if you remember, and we're going to append to it this brand new string here. And what append does is it takes your list and puts whatever you append to it right in the end, so it becomes the last item of your list. Let's uncomment and let's see, and there you go. Now the last element of our list is hi from the last index of your list. Okay, now we've covered this. The important thing from here, the important thing that you should take with you is using dir to find out what methods you can use with each individual element, and you have to learn what each individual element can do, and more importantly, what it cannot do. So let's comment that out, and maybe that one too. And let's move on. So this is a tuple. Tuples are slightly different. They're still ordered like lists, so they have a predictable order to them, but they are sort of a little bit lighter than lists. Let's go ahead and print that out into the console. As you can see, they are all the information is encapsulated between regular brackets, not square brackets, and they have a different dir. They have different methods that you can use with them. So let's see what kind of dirs they have. Ignoring the dunder right here, you can see we have only count and we have index. Now count, we already know what count does. So you could think of tuples as kind of a lighter version than lists. They, I think they take up a little bit less memory. They're a little bit lighter to work with. So the interpreter is not so challenged to work with them. Don't quote me on that. I'm not 100% sure about anything I'm saying here. That's not the point of this channel. The point of this channel is that I learn crap while I pretend I am teaching it, literally to 0 subscribers. So let's go ahead and print that out. Now, what does this do? We're using, remember, from the dir here, from this, from all the available methods that we printed for my first tuple, we saw that we could use the we could use the index method, and now we're using it. And so we're saying print the index 22 of my first tuple. So we specify which one, and then we say use the index method for this tuple, and then we have 22. Now what this does is it iterates over, it goes through each individual element of this tuple, and it tells you where it is. It tells you what position it's in, because remember, tuples are ordered. They remain in the exact same order the whole time. So let's go ahead and do 24, for example. And in this case, what we're going to get? We're going to get 0, 1, 2, 3. We're going to get 4 as a result, because the index of 24 is 4 right here. Okay, let's move on. And let's cover ranges as well. So a range like that, this is a built-in function into Python, but also its own separate data type. So let's print it out. What do you think is going to be the result of range and then in brackets 21 to 41? Let's see. Well, it's we get data type range with the specifications from where to where. But if you remember, what we could do is use the dir and see what we could do with that range. And if we ignore the dunder methods again, we could see that we could count, index, start, step, and stop. So let's start with... Oh, I have I have phrased this as a question. What do start, stop, and step do? Okay, well, I guess that we have to research while we're not recording. So print my first range. What have I done here? Let's see what that is. Okay, so we could actually grab what this is. Range 21 to 41 is a range of whole numbers of integers that starts at 21 and finishes at 41 or at 40, including, I think. So what it could do is, now we grabbed the first element, much like with a list, if you remember. You could grab an element of that range. So if we grab the index 1, which is the second element, this should be 22, and so on. So you could go 3, and so on. So what range does is just creates a sequence of numbers that are in order from a certain starting point to a certain finishing point. So let's go range, let's see the 20th index, because we have exactly 20 numbers in there. Well, actually, apparently we have 19. So let's go with 19th index, and this is 40, because it does not include 41, the last one. So what range does is it takes a sequence of numbers that are in a range, essentially. And this is a separate data type in Python. And apparently you could do stuff with it, like start somewhere, stop somewhere, and step. I think step is just to return the numbers, but skip over. So when you give it a step argument, it's going to skip a specific amount, a specific number. So you can start at 21, and if you give it a step argument of 3, it's going to go to 21, 24, 27, and so on. This is useful for arithmetic or some logic that you're doing. I don't know, whatever. And now let's move to hashes. So hashes are a separate or mapping type, it's called here, hash map. In Python, this is called a dictionary. It's completely different from a list. I used to really confuse hash maps with lists and tuples and stuff like that. It's a completely different affair. It's a very different data type that you ideally shouldn't mix the two. So what does a hash map do? Well, you have key value pairs, right? So they're separated by commas. By the way, you're using the curly braces, as you can see, and you have key value pairs separated by commas. Now, what does this mean? You could think of the key as the address number for something, and the value as what is on that address. So you could fetch those values by referencing the keys. So here I would recommend, once you're actually done watching this confusing mess, learn more about all of those by doing a few projects, and we're going to do a few together as well. And then go to Udemy and find a course that's called Python Deep Dive. And there's an entire section dedicated to hash maps and to dictionaries and stuff like that. And it's an amazing course, very well explained. Definitely recommend that one. So let's play with the dictionary a little bit, right? Let's start by demonstrating how we can fetch values from the dictionary. So the way we fetch values is so first of all, we call the dictionary and we say, give me the value for key 1. Remember, this is the address, and now we're going to get whatever is living on that address, and we're getting value 1. This is a string in this case, but it doesn't have to be a string. Why don't we make it an integer? And if we make it an integer, we get an integer back. Key 2, value 2, well, what's going to happen if we fetch key 2, for example? So see what we're doing? We're referring to the key, but we're getting the value. And there's way more to it. You could iterate over or use just the keys, or just the values, or the entire thing, the entire pair. So what's going to happen if we do this? So we are now just printing the keys of that dictionary, and so we get a list of all the keys. As we said already, they could be used for information in themselves. They don't have to just point towards the values. But we could also just print the values. Now we're just getting all the values in that hash map. And what about we print the whole thing? Well, we have to use the items method. Remember, you can use dir to get everything to learn about everything you can do with this data type. And that's exactly what we're going to do. So eliminate the dunders and focus on what we could do now. So we can clear, copy from keys, get items, keys, pop item, set default, update, and values. Just play around with all of those until you learn what they do, because sometime for some project you may need the functionality of one of those, and if you're under pressure or you don't have time, it's better to at least know that it's a possibility to do something with those. So how would you add something to the dictionary? Now with the list we were appending, but with the dictionary you don't need to do this. You could actually just say something like this. You could call the dictionary and you could say, well, here's a new key. Remember, that's how we were calling the value by referencing this key. So you could say, here's a new key and it's going to be equal to a new value. And now we added something to the end of that dictionary. So there you go. The final element is key 4 and value 4. And now let's move on to sets. Now, why are sets different from dictionaries, from lists, and from tuples? They still, as you can see, hold a bunch of things together in some kind of sequence. Well, the issue with sets is that they're very light. And so, well, that's not the issue, that's the strength. They're very light, but they don't hold the order. You cannot guarantee that you're always going to get this exact order, which could be vital for your program. So let's go ahead and print this set right here. And in this case, it does hold the order, but that's because those numbers are so small and so sort of common and predictable that the Python interpreter, I think, has already given them addresses and it knows where they are and it is capable of holding the order. Because at the beginning, when you initiate your program, a certain set of numbers are already stored in memory and Python knows where they are. It knows their addresses. And in this case, I think it just figures out that it should put the string in the end because it's just one string and 5 integers. So every time you refresh it, it stays the same. But this is deceiving. Sets are not like that. Sets are not ordered. So let's demonstrate this by throwing at the Python interpreter something a little bit bigger. Now those numbers, they are not stored in memory automatically when you start your interpreter. They have to be created by the interpreter as it moves from top to bottom. So let's see if they're going to retain the order. And as you can see, no, not at all. So we start with this number here, and then we get 244, so we get this number, and then this one. It's a mess. And when we refresh, well, it didn't, now it changed. Now the string is on the second place. Now the string is on the first place. So, important thing here, the set does not maintain order. That's the main difference. And of course, well, you know already what's coming. We print dir. We remove the dunders, and wow, the set has a lot of stuff you can do with it. So it's definitely very versatile. And let's move on because I am already getting tired. My first set update. Okay, so I'm demonstrating here the update function of the set. And what's happening here is, wow, okay. I think what we're doing here is we are getting my first set, which was this one right here, and we are adding to it. We're adding to it something from my first list, which was the list we used earlier. And let's print it out because otherwise, oops, sorry, because otherwise we don't see the changes. So my first set like this. And so what's happening here is we get the update is essentially just adding additional items to it. Like we said, sets are not ordered, so it doesn't matter if they're in the end or not. In this case, it's appending them to the end, but as you can see, when we refresh a few times, well, things get a bit complicated. It starts messing things up. So what this is doing is slicing my first list, the one we used earlier, and then just adding the elements to the set. So as you know already, you can have different data types interact with each other, and you could get something from one and use it in another, and yeah, that's pretty flexible like that.